Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between random forest and AdaBoost categories. Size. Random forest use full size decision tree with no predetermined depth size. AdaBoost AdaBoost combines a lot of weak learners to make classification. The weak learners are also always stumps. Distribution of say for each tree. Each tree has an equal vote on final classification. Some stumps get more say in the classification than others. Classification accuracy. Random forest often gets outperformed by AdaBoost in terms of classification accuracy. AdaBoost is often much better at making accurate classification. Tree construction order. Each decision tree is made independently of the others. Each stump is made by taking the previous stump's mistake into the account. Overfitting tolerance. Random forest is less sensitive to overfitting as compared to AdaBoost. AdaBoost is also less tolerant to overfitting than random forest. Data sampling technique. Random forest, the training data is sampled based on the bagging technique. AdaBoost is based on boosting technique. Estimate calculation. Random forest aim to decrease variance, not bias. AdaBoost aim to decrease bias, not variance. In sampling operation, random forest employ parallel assembly, forest procession, trees in parallel, allowing jobs to be parallelized on the multiprocessor machine. AdaBoost make use of sequential assembling. It takes a step-by-step methods. Moving question: difference between batch gradient and stochastic gradients. Batch gradient, compute gradient using the whole training sample. Stochastic gradient or SGD, compute gradient using single training sample. BGD, slow and computationally expensive algorithm. SGD, faster and less computationally expensive than batch gradient descent. No, BGD not suggested for use training sample. SGD can be used for large training sample. BGD deterministic in nature. SGD sarcastic in nature. BGD gives optimal solution given sufficient time to coverage. SGD gives good solution but not optimal. BGD not no random shuffling of points are required. In SGD, the data sample should be in a random order, and this is why we want to shuffle the training set for every epoch. BGD cannot escape silo local minima, especially easily. Sarcastic gradient descent can escape shallow local minima more easily. BGD convergence is slow. SGD reaches the convergence much faster. Moving question: difference between supervised learning and unsupervised learning. In supervised learning, required labeled data, input and corresponding output on target. Unsupervised learning required unlabeled data, only input feature, not target variable. Primary objective to predict the output value or class for new unseen input. Unsupervised to discover hidden pattern, structure or relationship within the data. Training feedback. The model learn from the correct answer labeled provide in the training data set. The model learn autonomously without explicit feedback or correctness. Core task classification, discrete output, and regression, continuous output. In unsupervised clustering, grouping, and association, rule discovery, and dimensionality reduction, evaluation matrix. In supervised learning, accuracy, precision, recall, F1 score, RMSE, R2, AUC. In unsupervised, Salute score Intriga, SSE, Purity, Jaccard index, typical algorithm, linear regression, logistic regression, decision tree, SVM, neural network, unsupervised, k-means, hierarchical clustering, PCA, priori, autoencoders, complexity generally simpler to evaluate and deploy, but data labeling is costly. Unsupervised can be more complex to interpret and validate result, but data acquisition is cheaper. Real world example is spam detection, image classification, stock price prediction, unsupervised market basket analysis, customer segmentation, genetic sequence analysis. Please like, subscribe the channel. Thank you.